Hello there. Welcome to Autism Behavior Services. I'm Chloe. Today we have a very special and interesting guest. His name is Evan Valdes, and he is a rocket ship engineer. In this virtual meeting, he is going to tell us how he became a rocket ship engineer, some of the most exciting projects he has worked on, and what you can do to study to become an engineer. Let's hop on this call now.
Hey there, Chloe. My name is Evan Valdes. I work at NASA, and I'm the lead thermal engineer on my project there. What I do is I make sure the different parts of the spacecraft don't get too hot or too cold.
Ooh, Evan, can you share with us how team sports translate to the workplace and importance of a team environment?
Yeah, growing up, I played soccer, football, and baseball, and now I currently play ultimate frisbee. I captained my team in college and also the Los Angeles men's team. And here's a picture of one of the years where I won a national championship.
Wow, that's amazing. Your team won a national championship. I would imagine working on a complex project like a mission to Mars requires an amazing team effort.
Yeah, absolutely. Working together in team sports is really important because every person on the team is involved and helps us do well. And at work, it's almost exactly the same. It takes a lot of people working really hard together to make the things go into space succeed.
Yeah, I imagine working on exciting projects like missions to Mars can also be a little stressful. Do you have hobbies that allow you to shift gears and relax, other than like ultimate frisbee, of course?
Yeah, I love the outdoors. I like camping and backpacking. Here's a picture of one of the trips I went on through Utah in Zion.
I've always wanted to go to Zion. It looks beautiful. But I have another question. Becoming a rocket engineer sounds like an incredible accomplishment. We would love to hear your journey about how you became a rocket engineer. Can you tell us a little bit more about that?
Yeah, it started as, of course, in school, where I studied really hard. I always tried to do as well as possible in all my classes, but especially in math and science. And when school got really hard, I just always kept on trying until I could figure out the tough problems. Sometimes that took a lot of tries and I'd get things wrong, but in the end, I never gave up until I figured it out. And my job at work is essentially figuring out those really tough problems. So it set me up for what I do here at work.
So can you share with me what JPL is?
Yeah, JPL is the location where I work at. It stands for Jet Propulsion Laboratory, and it's one of the NASA labs. And NASA is the government agency that makes things that goes to space.
Awesome. I heard JPL has an amazing history dating back to 1936 and has been at the forefront of America's greatest accomplishments with NASA. The work being done by JPL is changing our understanding of the world and space exploration for future generations. Can you share with us some of the most exciting projects you have worked on while working in this field?
Yeah, after college, I started working at Northrop Grumman, where I made missile defense satellites. After that, when I started at JPL, I worked on OCO3, which is currently on the International Space Station, and followed by MOXIE, which is part of the Mars rover that just landed on Mars. And right now I'm working on SWAT, which is scheduled to be launched to orbit the Earth in about 2 years from now.
So what exactly was the OCO3 project that you worked on?
OCO3 stands for the Orbiting Carbon Observatory, and it's an instrument that currently lives on the outside of the International Space Station. It is designed to measure the carbon dioxide in the Earth's atmosphere, and it uses what we call spectrometers to separate the sunlight that reflects off the Earth. And so by separating the atmosphere through carbon dioxide and oxygen, we're able to figure out how the atmosphere changes around the planet. And this is important because it helps us understand where that carbon dioxide is coming from. And so to help figure this out, we have a kind of like a wide-angle camera, scanning lens, and then also there's a really accurate staring lens that stares at exact spots on the Earth that we care about more. Is part of the Mars Perseverance rover that just landed, and so this will demonstrate the ability to produce oxygen on Mars, and it works by breathing in the Martian air, which is mainly carbon dioxide, and then it exhales oxygen, which we need for breathing and for making fuel. It does this using a method called solid oxide electrolysis, and that includes heating up the system to almost 1500 degrees. And by doing this, the oxygen is separated from the CO2. So after we prove that this works, the technology will be scaled up, and this would be able to support humans going to Mars and be able to get them back home safely in like 10 or 20 years. That stands for Surface, Water, and Ocean Topography. And this is going to be the first satellite that gives us kind of a complete global understanding of the Earth's surface water. It has a high resolution, wide angle capability that's way more accurate than the current satellites, over 10 times. So it can look at really, really fine details of how the land water and the oceans change over time. It uses this huge antenna to shoot radar at the Earth, and it kind of gets the information like how a bat signal works. So it bounces thousands of signals off the Earth and then looks at how long it takes to return back to the orbit. Also, it has these two deployable antennas, and these stick out from the side of the spacecraft, and it helps make a 3D image of the water surface based off of the different times it takes to get the signals back. So we'll use the data that we get from this mission to be able to predict the weather better and to make sure that there's enough water for those people who need it and to protect people from floods.
I do have a question for you. How long, has it always been a goal of yours to be a rocket engineer, or have you always wanted to do that since you were a child, or is that just something you once you went to college you wanted to go that route?
Sure, yeah. When I was in college, I had an internship, and I think it was after my second year, and that's where I really found out that I wanted to be an engineer. From classes, it was kind of just doing math and physics type problems. It was kind of hard for me in my mind to think how that's applied. But when I was on an actual thing, I knew I was in love with being an engineer, but I had not yet worked on space stuff. My last internship when I was a senior, I was at Northrop Grumman, where I was working on satellites, and I thought that was just awesome. The main reason I like satellites is because I don't live in space. And so by working on stuff in space, I couldn't really naturally understand how things worked. So I was always kind of learning something new. And that's why I love being an engineer, figuring out new problems.
Awesome. So Evan, many young scientists are going to be watching this, from grade school to students in college. The question they all want to know is, how can they become a rocket scientist too? Yeah,
I'd say there's a few really important things that you could focus on to be a rocket scientist. I'd say the first thing is to always keep on asking questions and learning about new things, especially those that are interesting to you. And then the next is that no matter how smart you are by yourself, there's no one that can build a spacecraft by themselves. And so you're always going to be having to work with others. And so in school and with others, be sure to just do your best in the team projects and be a team player. And then the last thing I would say is be able to explain what you figured out. Some people are really smart, but they're not able to share that information with others. And so as scary as they might be, working on those presentations in front of the class is what really helped get me ready to be able to do similar kinds of presentations at work.
Awesome. Now I hear your nephew had a little incident in the kitchen and burned the power cord for the toaster. Like most people, they thought it was headed to the trash, but you saw an opportunity. Can you tell us what you did?
Sure, it indeed had gone to the trash, and so I got that toaster out of the trash. I knew that I could fix it. Being an engineer is all about solving those problems and helping others who need it. And so every day when I see a problem that can be fixed, I kind of get a little bit excited and I'm up to the challenge. And so in this case, I challenged myself to learn something new. I've never taken apart a toaster before. And so even though I didn't know how to fix it, I gave it a shot and I was confident that I would be able to make it work. And so here's a short little clip of me fixing that toaster. For today's home project, we're going to be repairing this toaster that has a melted plug on it. I have found this old computer power cable and it has the exact same wire gauge as this toaster cable. My thoughts are to either cut this cable and then try to replace it with this plug, or the other option is to try to take this apart, see how the inside works, and then potentially replace the entire cable. So we took off the bottom feet by taking apart these clips and screws, and it looks like this power cable comes in here and splits off into 3 wires, 2 going to this circuit board and another going to ground here. And so it would be a more cleaner look if we just replace this entire cable instead of having a multicolored cable at the end. So we're gonna take off the end of this connector and then splice in the 3 wires inside this cable into these, and then coming at the bottom, you'll just have 1 black cable when we're all done. All right, so out with the old and in with the new. We have unclamped the old location for the gray wire and wrapped electrical cord around these 3 wires from this black cable. Here's what a cord looks like. We have 3 cables inside this other cable, and so these old 3 wires here were coming out of the gray cable, and now we have these 3 coming out of this black cable that we need to connect together. I've already finished 2 of them, and here's 1 more left. We take this, I've stripped the ends of all of these, and now we put it inside this crimp connector, and we can just tighten this down. And then this is called heat shrink. We heat this with a heat gun here, and then this shrinks onto this cabling. Should I go fast forward? Alright, this is the ground wire, which is usually the green one. So it has a little place for it to get stuck inside here. And now, all we need to do is button it all up and put it back together. So along with doing the fun part, which is taking apart the wire, figuring out the issue, and making the fix, I did want to point out that a lot of times engineers have to do some things that are less glamorous, which in this case was polishing the case, getting into all the nooks and crannies, and making this finished product with the toaster that looks like new with a brand new replaced cable.
Now I imagine it is not easy to get into this field, and internships are a great start. Can you share some tips on how you got an internship in this field?
Yeah, so this was probably one of the most challenging parts through college that I can remember. A lot of people have a family member or a friend, some kind of a connection that can get them that internship for free or with a lot less work. But for me, this was an extremely hard process and discouraging at times. So even though I had been working since I turned 16, none of these jobs were ever engineering. I tried to get a job and applied at over 80 different companies and was only offered a job at 2 of them. And so this was a lot of failure and a lot of just keeping on going, knowing that I could do it. I was also a sophomore trying to compete with seniors. And so maybe that was part of it. But I was convinced that I was the best person for the job. And so the lesson I learned here was that even if you fail the first time or the second time, or even the 50th time, that you should not give up. Just keep on going for it.
Lastly, Evan, would you like to show any of your other personal projects that you have worked on yourself?
Yeah, so here's a couple other examples of just things that come by on a day-to-day basis. One year I wanted to give my wife a new car stereo for Christmas, and so here's a picture of the wiring harness that you have to rebuild from the original stereo that comes in, and it changed to the one that does the video directions and a backup camera. So there's a lot of wires in the background behind there that you see behind the buttons.
Yeah.
So the next thing is a 3D model of a crib I made. And so at work, we have to make 3D models of spacecrafts. So we model down to the nuts, bolts, every wire is included. And so here I just did a 3D model of the different wood shapes I would be cutting and painting, and it helped me kind of organize and figure out what shapes to make things. And here's a picture of the crib that I made for the friend in the nursery room. So it was a success, and it's still currently being used.
It's nice.
Lastly, I'd like to show and tell some of these thermal blankets that I work with. It's called MLI, multi-layer insulation. And so what these blankets do in space is help keep the electronics at a nice and cozy temperature. For a lot of pictures of spacecrafts, you'll see them clad in gold or silver, kind of like this. And it not only makes you look like a futuristic robot, but it makes you, the temperatures do well in space. And so you can see the inside of this is made by many, many, many layers. This is 15 layers of some aluminum foil type stuff separated by a mesh. And so what this does is you have this reflective material, and let's say it's hot on one side and you want to keep it cooler on the other. It partly reflects off the sun, and then for each layer, it prevents the heat from going through, kind of like a rubber glove when you're touching a frying pan in the kitchen. And so through tools like this, or different optical properties like paint on the outside of a spaceship, we're able to keep our temperatures how we would like them. And that's the kind of stuff that I work on to make sure we get right at work.
Awesome. So Evan, thank you so much for joining us today. Is there anything else you would like to share with us in the preparation to becoming a rocket ship scientist?
Yeah, I would say that through being in school, get involved in the community and do stuff that you really love. If it's a hobby, volunteering, getting out to help others. And remember, stay creative, keep on trying to do new things. Ask questions about the things that you love. And the best ideas that engineers have are all those things that others thought wouldn't work. And so if you feel confident about it, then keep on going.
Awesome. Well, thank you all for joining us today with our good scientist friend, Evan. So until next time,